Another problem, find divergence of R bar and curl of R bar, where R bar is equal to xi bar plus yj bar plus zk bar. We know that divergence of any vector function is dou by dou x of first component plus dou by dou y of second component plus dou by dou z of third component. Therefore, divergence of R bar becomes dou by dou x of x plus dou by dou y of y plus dou by dou z of z, or it becomes 1 plus 1 plus 1 is equal to 3. We also know that curl of f bar is the determinant with elements row wise I bar, j bar, k bar. The differential operators dou by dou x, dou by dou y, dou by dou z, and then the components f1, f2, f3. So, curl of R bar becomes determinant with elements row wise I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z, the operators in the second line. Third line, the components x, y, z. So it is I bar into dou by dou y of z minus dou by dou z of y plus or minus j bar into dou by dou x of z minus dou by dou z of x plus k bar into dou by dou x of y minus dou by dou y of x. This is equal to 0. Let's discuss one more problem. If a bar is a constant vector and R bar is equal to xi bar plus yj bar plus zk bar, prove that curl of a bar cross R bar is equal to 2a bar and divergence of a bar cross R bar is equal to 0. We take a bar as a1i bar plus a2j bar plus a3k bar. A bar is a constant vector, implies a1, a2, a3 are constants. We know that R bar is xi bar plus yj bar plus zk bar. So, a bar cross R bar is the value of the determinant with elements row wise I bar, j bar, k bar, a1, a2, a3 and x, y, z. So this becomes I bar into a2z minus a3y plus j bar into a3x minus a1z plus k bar into a1y minus a2x. Now we can determine both the divergence and curl of this vector. Let us initially determine curl of a bar cross R bar. We know that it is the value of the determinant with elements row wise. First row I bar, j bar, k bar. Second row the differential operators dou by dou x, dou by dou y, dou by dou z. Third line the components of a bar cross R bar, namely a2z minus a3y, second component a3x minus a1z, third component a1y minus a2x. On expansion, we get I bar into dou by dou y of a1y minus a2x minus dou by dou z of a3x minus a1z plus or minus j bar into dou by dou x of a1y minus a2x minus dou by dou z of a2z minus a3y plus k bar into dou by dou x of a3x minus a1z and then minus dou by dou y of a2z minus a3y. After performing partial differentiation, you get I bar into a1 plus a1 minus j bar into minus a2 plus k bar into a3 plus a3, or it becomes 2 times a1 I bar plus a2 j bar plus a3 k bar, or it becomes 2 times a bar. Let's now determine the divergence of this vector. Divergence of any vector is dou by dou x of first component plus dou by dou y of second component plus dou by dou z of third component. So, divergence of a bar cross r bar is dou by dou x of a2z minus a3y plus dou by dou y of a3x minus a1z plus dou by dou z of a1y minus a2x. The first component, it has no x term. Second component has no y term. Third component has no z term. So, their partial derivatives with respect to x comma y comma z will be respectively 0, or finally we get 0.